What if the universe is filled with billions of planets, yet we have never found a single alien civilization? The silence is deafening. The observable universe is vast beyond comprehension. It contains hundreds of billions of galaxies, each a sprawling island of stars. Within this cosmic sea, we find our home, the Milky Way galaxy. It alone contains billions of stars similar to our Sun, spanning 100,000 light years. For millennia, we looked at the night sky and wondered if other worlds orbited distant stars. In just the last few decades, the exoplanet revolution has provided an answer. Space telescopes like Kepler and the James Webb have revealed a profound truth. Nearly every star in our galaxy hosts at least one planet. We are now identifying planets within the habitable or Goldilocks zone, where conditions might allow for the presence of liquid water. This discovery shifts our perspective, transforming the galaxy from a silent void into a neighborhood teeming with potential new worlds. Consider the sheer magnitude of our own galaxy. Within the Milky Way alone, there are between 100 and 400 billion stars. With billions of Earth-sized planets orbiting within the habitable zones of these stars, the odds for life to emerge are statistically vast. If life follows the law of large numbers, the universe should be teeming with active, communicative civilizations. The numbers alone suggest we are not alone. Could life be a cosmic anomaly? The rare Earth hypothesis suggests that the conditions required for complex life are not merely common, but require a unique, highly specific sequence of events. Complexity relies on a perfect storm: plate tectonics to cycle nutrients, a magnetic field to shield our atmosphere from solar radiation, and the precise orbital location for liquid water. Consider our moon. It is unusually large compared to our planet, acting as a gravitational anchor that stabilizes Earth's axial tilt, preventing extreme climate shifts that would devastate complex life. Without this improbable confluence of events, the universe might remain a silent, microbial wilderness. We may be far rarer than the stars themselves. Perhaps the silence of the cosmos is not due to a lack of life, but a lack of time. Intelligent civilizations may be inherently fragile, possessing a short lifespan before they inevitably collapse. Technological maturity often brings existential risks. Nuclear conflict, runaway climate change, or the emergence of hostile artificial intelligence are common failure modes for advanced societies. The window of observability, the time a civilization spends as a technological power, may be measured in mere centuries. Before they can signal across the stars, they succumb to their own invention. The Fermi Paradox leaves us with a chilling possibility: the Great Filter. Imagine evolution as a series of improbable leaps, each one a gate that life must pass through to become interstellar. From the spark of simple life to the rise of multicellular organisms, then intelligence and technological civilization. Each step is rare, but the Great Filter is an invisible barrier, so difficult, so insurmountable, that it prevents most life from ever reaching the stars. This is the filter, a point where probability collapses. It is the bottleneck of existence. If the filter is behind us, we are incredibly lucky to be here. If it lies ahead, we may be approaching our own inevitable extinction. The Great Filter theory suggests there is a threshold, a barrier so difficult to cross that it halts the development of most civilizations. If the filter is behind us, it means humanity is a cosmic anomaly. The origin of life itself, or the leap to complex cells, might be the improbable step. We stand here at the threshold of technological civilization. If we are rare, the void of space is silent, because the odds were stacked against everyone else. But consider the weight of this possibility. Has the universe already been pruned? Is our existence a testament to surviving the impossible filter? If we are past the filter, we are the lucky inheritors of a silent, empty expanse. The silence of the cosmos is not a threat, but a gift. If the Great Filter is not behind us, we face a far more terrifying reality. It means that the bottleneck of evolution lies in our future. It suggests that all advanced civilizations, as they achieve technological maturity, inevitably trigger a mechanism that halts their progress permanently. Whether through nuclear conflict, artificial intelligence, or ecological collapse, this theory proposes that the universe is a graveyard of species that failed this final test. If we are indeed reaching the edge of this filter, the silence of the cosmos may not be a mystery, but a warning of what happens when civilizations try to reach for the stars. Consider a new perspective on our silence. What if the universe is not empty, but filled with predators? In the dark forest theory, civilizations treat the universe like a hunter in a dark woods. Any sound made by a target reveals their location, leading to immediate elimination. Consequently, intelligent species remain perfectly silent. They hide in the shadows, not because they are alone, but because they are terrified of being found. In this framework, our own radio broadcasts may not be a friendly greeting, but a beacon calling out to those who prefer we remain in the dark. We have been scanning the heavens for decades, primarily using radio telescopes, but we assume that any advanced civilization would broadcast in the same way we do. Consider laser communication. It is vastly more efficient for interstellar data transfer than radio. Our current arrays are built for the noise of the past, not the precision of the future. Advanced species might even use neutrino streams, particles that pass through matter entirely. These messages are invisible to our current technology, leaving us listening for whispers in a room where everyone is speaking in light. A significant solution to the Fermi Paradox lies in the window of observability. We assume civilizations will broadcast their presence for eons, but history shows technology evolves at an exponential rate. Earth has been leaking radio signals into space for less than a century. This noisy phase is likely a temporary, inefficient stage of technological development. As a species matures, it shifts toward highly efficient directed communication, like lasers or fiber optics, which are nearly impossible to detect from light years away. Advanced civilizations don't go silent because they are dead. They go silent because they have become efficient. Their signals are hidden in the background noise of the universe. The search for extraterrestrial intelligence, or SETI, is one of humanity's most ambitious scientific endeavors. We use vast radio telescope arrays, like the Square Kilometer Array, to scan the heavens. These dishes act as giant ears, listening for artificial pulses or repeating patterns that cannot be explained by natural phenomena. We are sifting through the cosmic static, searching for the unmistakable signature of technological intent. While we have yet to confirm a deliberate transmission, every day of observation refines our methods, pushing the boundaries of what we can detect in the silence of space. We are shifting our search. For decades, we listened for radio waves. Now we use the James Webb Space Telescope to perform atmospheric fingerprinting. As an exoplanet passes in front of its host star, light filters through the planet's atmosphere. By analyzing this light, we can decompose the planetary atmosphere into its chemical components. We are looking for specific technosignatures, industrial pollutants like CFCs. These compounds do not occur through natural, geological, or biological processes. Advanced AI algorithms now scan this data, identifying patterns that would define a technological civilization. One proposed solution to the Fermi Paradox involves von Neumann probes, theoretical autonomous spacecraft capable of self-replication. A single probe could theoretically colonize an entire galaxy in a few million years. Upon arriving at a star system, these probes would harvest raw materials from asteroids or moons to construct perfect duplicates of themselves, continuing the cycle to neighboring stars. If this is possible, why is space silent? Perhaps these probes are microscopic, making them invisible to our current sensors. Or they may have arrived eons ago and gone dormant, awaiting a signal that never came. Or most chillingly, they are already here, observing us from the shadows. Consider the possibility that we are not alone, but merely shielded from the truth. This is the zoo hypothesis. Advanced civilizations may treat Earth as a cosmic nature preserve, observing our development while strictly adhering to a policy of non-interference. Like a scientific study, they may wait for us to reach a technological maturity before revealing their presence. We look into the void, expecting an echo. Instead, we find only silence. It is not merely an absence of sound, it is a profound existential data point, suggesting that we are far more alone than we ever dared to imagine. Consider the silence not as an absence, but as a choice. What if we are not the explorers, but the observed? Perhaps they are looking down at our planet, intentionally avoiding the crude, noisy static of our radio signals. A civilization that observes, but does not interfere. A silent curator for a world not yet ready to know the truth. Are we the subjects of an experiment, or simply not yet worth the conversation? We are left with a binary choice that defines our place in the cosmos. Either we are truly, fundamentally alone, a singular spark of consciousness in a cold, indifferent void, or the galaxy is a bustling metropolis, an intricate tapestry of civilizations interacting in ways our current senses simply cannot detect. The silence may not be an empty room, but a language we have yet to learn. The Fermi Paradox remains our final mystery, a silent testament to the vastness of what we have yet to understand. Until we discover the truth, the Fermi Paradox remains one of the greatest mysteries in the universe. Subscribe for more mind-blowing space mysteries.